Hi there, welcome back to the channel and welcome to the fourth video in the restoration series of the SABA Meersburg 100 full automatic. And it's nowhere near full automatic right now. I left off with a problem with the tuning. The actual automatic tuning wasn't finding in one direction, it was only finding in the other. I did some reading, I did some rewatching of the videos on the previous series that I did on this type of radio. I've done about 4 of them, but I think I've only got one. I believe it's one that's that I've done a series on. So I rewatched my videos, boring as hell. But anyway, I learned a few things again, and I decided to tackle this problem today. And what I ended up doing, as you will see if you watch the video, is I did an IF alignment, and I came a cropper with the with automatic tuning. So this is giving the game away right now. At the end of this video, I still do not have the automatic tuning working. And I can't really figure out why. I've got an idea, but I still need to do a bit of work and reading on it to try and sort out the reason and try and sort out the problem. So if you've got some time and you want to see me go through my frustration, stick around and enjoy the video. When I finished off last time, we didn't have the automatic tuning working very well at all. It was turning, but very, very slowly, and I wasn't sure what the reason was. I'm still not sure what the reason was, but I've done what I wanted to do before jumping to any conclusions, and that is to do a recap of the motor section. Now, when I did the recapping of the radio, I did not touch on the motor section at all. In fact, I didn't even check the power supply on that. And the reason for that is I just like punishing myself. But anyway, the point is, what I decided to do first, before panicking or jumping to conclusions, was to replace the caps that needed replacing on that section. And there aren't that many of them. If we look at the schematic, we have to look at things like that. So that circuit was checked. That capacitor was replaced for a 2.2 microfarad capacitor. It's a high voltage cap as well. There's another 2 microfarad over here. There are a couple of smaller paper caps, 47 and 120. This was actually 150 in the radio, so I replaced it with 150. Good thing, because I can't get 120s. What else did I replace on here? I think that's about it. The rest was done previously. So ultimately, well, what did I replace? I replaced 1, 2, 3, 4 capacitors. That's about it. And I checked some of these lines and they all seem to be fine. So that's the time to start testing this thing. But there are 2 caps here that I've got to draw your attention to, and that is this bugger here and this bugger here. Now, these are basically the motor caps, and they are pretty hefty and they are very difficult to replace or to find replacements for. So I did all the changing that I could without messing with those 2. And those 2 are these guys over here. That one there and that one there. Now, these are AC capacitors. Now, it doesn't mean you can't use DC caps, but I really don't think that putting a, 0.35 microfarad on there or 0.4 is going to do the same thing. I'm not sure. I've read some of the forums and they say that you can actually replace this with normal film caps as long as they've got the rated voltage. Remember, this is AC voltage. So if you've got like 260 volts AC, the caps have got to be rated for 1.4 times that, because it's the peak limit. But I really didn't want to change this. And so this one is 0.35 and that one's 0.4. What I did do is I tested them. This one tested perfectly well. And that one tested a little bit high. I think instead of 0.4, it was 0.5 or close to 0.5 microfarads. So that might be the reason. I don't think so. But anyway, the point is these guys stayed as they were. And what I'm going to do now is test it, because there's one other issue that we need to address, and that is the tubes, which I haven't replaced at all. And that is those 2 tubes over there. It's an ECL 80 and an EABC 80. Now, I actually was surprised that I do have spares for that. The EABC 80 is quite commonly used in these radios, or the simpler version of these radios. The ECL 80 is not as common, but for some reason, sometime in the past, I got one, and I've got a spare one, and I want to try that later. But I want to see if these capacitors that I've replaced make any difference to our tuning issue. So let's turn it around and try it out. All right, here we are. Well, what do you think is going to happen? I'm going to switch it on. and I'm going to hit search. Nah. It's exactly the same as before. No, capacitors didn't do it. Now remember, it could still be those two big caps, the motor caps that I haven't changed. But let's try the other option. I've got into the habit of ordering extra tubes whenever I order tubes for a radio. And this is one I had here already. I'm not sure which one this is. This is the ABC 80, so it's this one. I remember at one point I cleaned it off and it just took off the marking, so I wrote it in Sharpie. But I believe this is pretty good. And here is a TELEFUNKEN ECL 80, which, as I said, I don't remember when I got it, but it looks like new old stock. It looks like it's in perfect condition. In fact, I seem to remember one of the viewers said he has a friend that sells tubes, and he asked me for a list of them, and I think that was one of the ones he sent me. So thank you. I'm putting this away. I've got two tubes there that should be good, and with these automatic tuners, the tubes need to be in very good condition. So this might be it. Let's try it out now. Okay, I switched it on. Tubes are warmed up. Let's see what happens. Ha ha ha! Why didn't it find it there? Hang on a second. Yeah, this has happened to me before as well. It's finding the next station. Let's put the volume up. It's on medium wave. It's finding the station in one direction. And you can see the dials moving this way. But it doesn't find it in the other direction. So it slows down because it's sort of getting a signal, but it's not finding it. It's not stopping for it at all. Now, if I go the other way, this doesn't surprise me because I had exactly the same issue with another one that I did quite a while ago. It wasn't the Breisgau. I can't remember if I did a series on that one. It's also not going very fast. I seem to recall these things turning a heck of a lot faster. The actual, there's a fast and there's a search on here. Yeah, it's finding it. And if I try to turn it, it turns, but it's quite a bit of resistance. Can feel it trying to hold it there. If I turn it off, I can then move it freely. So one more thing I want to know is what happens when it gets to the end. Let's get to the end, okay? It should stop. Oh no, that's not good. It doesn't, I was looking for it earlier. I was looking for these end switches. I believe it was the Breisgau where I pointed it out. Let me put this off. It has an end stop switch. So when this thing gets to this end, it switches off the motor. When it gets to the other end, it switches off the motor. This thing doesn't seem to have it, which is a bit of a shame because I don't know how they expect you to operate this. If you put it on search and you walk out the room, this will be forcing itself non-stop, which is a bit of a bummer. Unless the switch isn't good, but I don't believe there's a switch. I have not seen a switch on these ends. It's usually, I think it was linked to this pulley. I'm not sure now, can't remember. Okay, the point is our tubes made all the difference, and it seems that the motor is actually turning quite well. I don't think it's turning as fast as it should, which means this might still need to come out to get cleaned. And it's also not stopping at stations when it moves from this side to that side. It finds them and stops coming this way, but not going the other way. So that means there's probably an issue with the alignment, and there is an alignment for this. And what you need to do is, I believe you need to do the AM and FM, the IF alignment first. These things, this thing works for FM and AM. There is a sort of an IF transformer in here, which you align for the AM, and then there's another one for the FM. And I think it would be quite pointless to try and align this without first doing the AM and FM IF alignment. So let me think how I'm going to do this. I think what I'm going to do first, I'm going to stick to AM for now. I'm going to do the AM IF alignment. The IF frequency is 460 kilohertz. I'll do that. I'll align the motor tuning for AM and see if I can get this thing to work a lot better than it's working now, both in terms of speed and in terms of, finding the stations when it goes from right to left and stopping. That has to do with that alignment. And there are pretty accurate or pretty clear instructions on how you do this on the service manual. And there is actually one for a Freiburg 125, which is practically the same in terms of functioning. And there's an English version of that service manual. So I'm not going to use the English version. I know how to read the German version for this particular radio, so I'm going to follow that. I'll be doing the IF alignment for the AM, and then I'll be doing the motor alignment for the AM. We'll see if we can get that to improve, and then we'll handle the FM later. Okay, at least we got some progress. It's just a shame that my last remaining ECL 80 is now being used. I'll have to try and order some more. Don't know where from, but I'll have to do some searching. Okay, so far, so good. The IF alignment here is actually a lot simpler than it might seem initially. This is a very complex radio, but the alignment instructions are very, very clear. And there's not really that much you need to do. They tell you to inject the signal into the grid of the ECH81, which is that tube over there. Now, I've done something since the last video, the last time that I did an alignment. I don't know who gave this idea, but I got one of these tube socket savers, and I saw this on somebody's channel. I'm afraid I can't refer to it because I don't remember who it was. But this thing comes out. You literally unscrew that, and the two parts separate, and you get access to the pins. And that allowed me to solder a little wire inside to pin 2. No, sorry, what is that? Pin 2, yeah, that one there, which is the grid. And that comes out the side here. That is the grid of the ECH81. And that's the one that I'm going to be using there. So what I've done is I've put the socket saver, tube saver, whatever you want to call it, in there. The tube goes into there. A wire comes out. And that's where I connect my signal to, over there. This one here is ground, and it actually goes to ground on the radio. And it also forms a shield around the signal coming all the way to the entrance to that tube socket. So I've got that signal coming in there. It's very easy to use. I've tried various methods. This one seems to be the one that makes most sense. So I want to thank whoever it was that gave me the idea that I now rudely cannot reference directly. I'm sorry. But that means the signal's coming in here. And the signal we're sending in there is a 460 kilohertz signal. It's the IF frequency. The idea is you send it as low as possible. I've got a 1.4 millivolts RMS signal coming in. It's the lowest I can make it. 1.4 millivolts RMS, that is the lowest that I can make it. So I'm sending that in with modulation. AM modulation. AM frequency is 600 hertz tone. It can be anything that's in the audible range. 30% depth. And it's coming out there. What I do, because the signal is still too hot, it comes into this stepped attenuator. I've applied 12 dB of attenuation. I can apply another 6, another 3. I'll sort that out when I get to that. That then goes into the grid of the ECH81 over there. I've got the speaker connected. I can put it on speaker or dummy load. I'll leave it on speaker for now. At the back here, I've got these two wires going to the analog millivolt meter, AC millivolt meter. It's set to AC volts, 300 millivolts range. And if I turn the volume up, we should be able to hear it and see the deflection. Now that's a fairly low level signal because I do have 12 dBs of attenuation. So the signal going into the grid is 1.4 millivolts RMS minus 12 dB. But I'll figure out what level I need once I've set this whole thing up. Now everything we need to adjust is actually right here. This is the first IF transformer. This is the second IF transformer. These three adjustments are for the AM. These three adjustments are for the AM. The other three on there and there are for the FM. Now, this is interesting because this particular type of IF transformer has got a coupling screw. So you can increase or decrease the coupling between those two coils. And that's the coupling adjustment there and there. And they actually tell you to adjust the coupling to undercritical, subcritical, and then critical. We'll look at the instructions and see what they mean by that. And what we're looking for is to peak the signal coming out of the audio by adjusting these two and those two. Okay, that's adjusting for the IF. Now, one thing I've already decided to do is I want to do a sweep of this. I want to be able to do a sweep adjustment to see what the bandpass shape is like. If you look at the schematic, you'll see that point D, which is over here, comes from the detector. See, this is the IF transformer secondary, the second IF. That is the signal coming out of there, which you've adjusted to peak, but it goes through a diode, it gets rectified, and it creates your audio signal over here. But the audio signal is actually superimposed on a DC component, which is an indication of the strength of your signal. So if you look at it here, for example, you will see what the strongest signal is by how much DC volts you're getting on there. And that amount of DC volts is negative. It's a negative voltage because of the configuration of this diode, the way this is configured. You've got cathode and anode that way. So you measure the DC volts on here, and if it goes higher, in other words, more negative, it means your signal's stronger. If it goes lower, it means your signal's weaker. So if you detect on there, if you measure there, you can get an indication on that. It's not a good idea to go right on there because you're in this tank circuit. So if you put a meter on there, you're going to probably shift the tuning of this tank circuit. So what you can do is move a resistor away. In other words, move to here. That's your point D. This voltage is going to give an indication, to the actual magic eye. So we don't want to play with that. So what we do is we look here. Where are we? There. That's 100K away from that signal. And that signal there is then the one that goes to your selector switch to choose between FM and AM. So we've actually got audio on there, but we've also got that DC voltage, which then of course gets blocked by this capacitor so it doesn't go into the audio circuit. But that's the best point that I found to connect it to. That's the one I use, or am using in this particular case. And let me show you what the result is. I'm going to set a sweep centered at 460 kilohertz. So I'm going to change this from modulation to sweep. The sweep is going to be linear, not log, linear. Center at 460 kilohertz. I'm going to give it a span of 28 kilohertz. I'll explain why in a second. And I'm going to give it 70 milliseconds. Again, I'll explain why in a second. The sweep is going out. And what I've done is I've taken the sync trigger from the back of this. Whenever you've got sweep, you've actually got a signal coming out the back, which is a square wave with a period of 70 milliseconds or whatever time you have here. So you can actually use that signal coming out of the signal generator as your trigger to the scope. And I'll show you how I set that up. So what I've got is I've got the trigger coming in here to channel 4, which is that one there. And what I've got now is I've got a square wave, as you can see there. Every time this starts, between the start and the end, it does one full sweep out of the output there. So if I set this, I've got two sweeps here. You see, I've got two periods here. If I do that, I've got one period, and I'm triggering the scope on this channel. That's why you've got the center, exactly the center of that wave, of that square wave, sitting on the center of the scale. Now, why did I make it 70 milliseconds? You see that? That's 2. That's 1. This has got 1, 2, 3, 4, 5, 6, 7. This is 5 milliseconds per division. So the total span of the screen is 70 milliseconds. So I'm getting a whole sweep from start to finish on here. And I know that because I've chosen a linear sweep, I know that my sweep is centered at 460, and I've got 14 below, 14 above. Remember I said the span was 28 kilohertz. So each one of these divisions is 2 kilohertz. It's just the way I like to do it. And then The channel 1 of the scope is the one that's going to the that output from the detector. And let me show you what I've got. This is what I've got. This is not the way you see it originally. I mean, the way you see it originally is it's going to be there somewhere. It actually might be all over the place. But what you need to do is you go into here and you invert the signal. Remember, this is supposed to be, let me show you. This is a negative voltage. I can show you. So what's happening is at 400 and, what is it, 460 minus 14 kilohertz, at 446 kilohertz, it's there. And then as the signal gets closer to 460, the signal, the voltage, the output goes more and more negative. See that? Till it reaches a peak, then it starts going less negative, and it reaches that there again. So we see a few things from here, which we'll conclude in a second. But the first thing I like to do is invert the trace, so that I can see it properly. I also shift it down so that I can get a better span, and I adjust the sensitivity so I can get a better span on here. That's still too much. That's sort of too little, so I can go on to fine adjust and just, I'm not interested in the absolute value, I'm interested in seeing it clearly on here. Now what can we see from that? Well, first of all, there's 460. This thing's not on 460. This is actually like 2 kilohertz below at 458. And I can prove that because if I go to the signal generator and I change the frequency, the center of the sweep, if I change it to 458, 457, 458, look what we've got there now. It's pretty much centered on 458. So this thing is not tuned or properly aligned. I can also make the span smaller. Let me make it 14 kilohertz. So that's 14 kilohertz across here now. So each one of these is 1 kilohertz. And we can see it's almost centered. I can actually play around with the center frequency a little bit more. Let's try 457.8. It's going the other way. So 458.1, 0.2, 0.3. That's exactly where it is centered at. 458.3 kilohertz is where it's actually centered at. And I want it at 460. So I want it, let me go back to 460. I want it there. So I need to shift this from there to there. Now I can do it on the scope itself. I actually prefer to do it using just not the sweep, but the tone, the modulation. I'll do it with that, and then I can check this and make any adjustments I need to get a nice curve. I need to get a very uniform curve. In other words, this has got to be sort of uniform on both sides of the 460, and that's the way it's probably the easiest to do. Now there's one other thing you need to do, and that is they tell us to feed a 4.5 volt signal into there, DC voltage, in a particular way. And what is that? Well, if we look at the instructions, we see here automatic blah 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 blah. Okay, German, which is a little bit of a problem for me. So what I've done is I've gone to the Meersburg 125, and I've got the same thing here. And this is what it says. Eliminate AVC by applying 4.5 volts from a low resistance battery to test points R negative and Y positive. Okay? R negative, Y positive. What are we doing here? Here's our Y, and Y is clearly connected to chassis. So they want the positive of that battery to be connected to ground. So the other side is negative, right? And where does it go to? It goes to R. And where is R? Remember, this is that socket, that fixture socket they have, the test socket they have there that looks like a pin socket, a tube socket, but it's not. We've got to look for R, and R is down here. Here's R. What is R? Well, R is actually the signal that's coming from this section here, which is part of the first IF transformer. And what it's doing is it's actually creating a DC voltage, very similar to what's happening at this side over there that I mentioned. But it's creating a DC voltage using this diode, which then comes down here. And then this signal, which has a capacitor here to filter it a bit, it comes along and it goes to, where does it go to? It goes all the way through here. And if you follow this signal, you can see that ultimately it goes through these coils, DC voltage, remember? Not affecting the signal coming in. It goes through these coils, it ends up at this tube here. So it actually ends up at the pin 2 of the ECH81. And what it does is it modulates the gain. It changes, increases or decreases the gain of this tube, this front end. And I think it actually goes to that one as well. If we follow all these signals, I think that goes to that one as well. But never mind. What it does is it changes the gain of this tube so that if you have a very strong signal coming in, and that strong signal produces a big negative voltage on R over here, that negative voltage goes back through there and it negatively biases this tube more negative, which closes it, so it makes its gain smaller, so then the signal gets smaller. If you've got a weak signal, then that's very low voltage, so it doesn't affect the biasing of this, doesn't cut this tube off, and the whole signal gets amplified more. This way you can get a very weak signal and a stronger signal, both of them going through the front end with almost the same gain. That's the idea. So what they want you to do is they want you to put a fixed negative voltage on there of 4.5 volts, so that whatever amplitude you are feeding into the grid of the ECH82, that modulated tone or whatever you're using, does not get affected by its strength. In other words, it doesn't activate the automatic gain control. You are setting a cutoff condition already so that whatever adjustments you make, this tube stays at the same gain. Now, all the SABAs use this, all of them that I've worked on so far. They tell you to annul the AGC. And what I've decided to do is just to make my life a little bit simpler. Instead of using a power supply, which I've used in the past, I built this. And this is just a battery clip for a 9-volt battery. There is a 5-volt voltage regulator on here with a couple of capacitors and a diode, and this comes out here. Now, what's going to happen is 9 volts goes in here with the battery, 5 volts comes out of the voltage regulator, the diode drops another 0.6 or 0.7 volts, so we're going to get 4.3, 4.4 volts coming out here. And this is what I'm going to connect on there. I'm going to connect the positive to Y. The positive goes to ground. So I've actually marked this on here to make it easier for me, but I'm going to switch everything off because I'm getting nervous. This thing is on, there's voltage there. I don't want to get zapped. I put a little label there with the pin IDs so I don't get mixed up. I've got my red going to Y, which is ground. I've got the black, which is minus 4.5 volts, going to R. I'm now going to connect the battery, and I should have my AGC circuit perfectly annulled without too many cables running around. And I'm going to switch this on, and we should have the same result. We should have a sweep. We might have the sweep slightly less in amplitude. No, we don't really. It's coming up there. Actually, it has reduced. You can see that. So the AGC, or that negative 4.5, has actually cut off that valve quite a bit. So what I can do is I can actually make the amplitude bigger by, that's too much. That's more like it. That'll give us a good indication. It also shows me something. This thing's a bit flatter than it was before, which means the AGC was already operating on here. This is actually fairly flat for an AMIF, and that's the idea because you want some bandwidth there as well. Okay, well, this thing is all set. Now all I need to do is take that away. I'm going to put it on modulation. You can actually see that on there, but that's not of interest to us. I want to see the meter over there, and we can peak it. Okay, now once you've set this up, and that takes about 3 minutes, and once you've explained it, which takes about half an hour, because I talk a lot, the actual alignment is very, very simple. We've got to do this guy and this guy, and what they tell you to do is to feed the signal in, and we can hear it, and you can see it on the meter. I'm just adjusting the pot, the volume pot. It's a fairly weak signal. I've got, what is that, 12 dB attenuation. I've got the battery in there, so I'm annulling the AGC, which is all fine and good. I'm going to put this on dummy load so we don't have to listen to it. And we look at the meter and we go to this guy and we decouple. This is the coupling. It's critical, so we decouple it. I'm just going to give it half a turn, not much more. And then we adjust these guys for max. And we look at the meter. Let's put the volume up a bit to halfway. There. Wrong way. It's going up a bit, yeah, and it's going down. There's our peak. Now this one. Oh, that got a bit out of that. Come back and do it again. You do this a few times, make sure you've really optimized it. There. That's a peak. Now what they tell you to do is to couple it critically again, so to a max. And I'm going to have to drop the volume a bit again. So I'm going to go to the max. That is sort of the max. And then they tell you to drop it 5%. So what I'm going to do is I'm going to move the volume control till I've got full scale on there. And then I'm going to drop it, decouple it 5%. That's it. That's done. Change the volume pot again to the middle. And then we do the same with this guy. Decouple. Put the volume up to the middle again, about the middle. Adjust this one. Whoops, wrong way. Looks like this was about peaked. That one. That looked like it was peaked as well. That looks like it's peaked. Go to this guy. Couple it critical to max. Drop the volume a bit. Go up again. Drop the volume a bit. Let's get it to there. Get to the top. That seems to be the top. I'm going to adjust the volume till I get full scale and drop 5%. That, my friends, is it. It's done. Okay. Now, what has it done to our shape? Well, let's have a look at that. Well, if I go from modulation to sweep, this is what we get. Two things are evident here. It's lower, but it's right in the middle. Let me just increase the amplitude a little bit more. I'm going to give it sort of, let's do it like that. And I'm going to give the span, I'm going to make the span 14 kilohertz. And I'm going to play with the fine adjustment. Just to get it more visible on the screen. Now, what can I do to make that more uniform? As you can see, it's slap bang in the middle at 460, so we've done that right. Let's see what happens when we play with these guys. Let's try that one first. Okay, that's shifting that way. See, that's giving me a flatter response, but it's moving away from 460. See what happens with the coupling. We can actually widen it with the coupling, but I don't want to do much of that. Let's try this guy. And you see that's looking pretty good. That's looking very good. Okay, that to me is a perfect IF curve. Now, whether the bandwidth's enough or not, I don't know, because they don't really tell us what bandwidth we're supposed to work for. But you see, that wasn't too bad. That was done according to their instructions with no visual alignment techniques, and the result is very impressive. So I'm inclined to say that we have done a very, very good IF alignment for the AM. It's perfectly centered at 460. It was at 458. It was slightly lower down here. In fact, at 14 kilohertz span, that's 7 each way, this would have been, there. So it would have been quite a bit off. We now have that thing perfectly centered. And that's it. That's the IF alignment for the AM. So what we need to do now is to align the motor. And we're also told how to do that. Now this gets a little bit messed up because you've got to connect quite a few things on here. We've got our socket over there, the test socket, and they tell us to connect a 0 center microammeter between M and Y, which is ground. And I've got that there. That's it there. That's M and ground. I'm using a very convenient lead on there for ground. That goes to the 0 center analog microammeter, which I'll show you in a second. And then they tell us to connect a DC voltmeter between points P and Y, so P and ground. So there's P there. That's going to my voltmeter, and there's my ground. And then you have to adjust. They tell you not to adjust at all. 601, 603, 605, that's the coupling, because that's done at the factory and it's actually sealed up. Then we've got the primary and the secondary. So the first thing they tell us to do is to set the amplitude of the signal till we've got about 12 volts on our DC voltmeter. Now that requires a pretty high input signal, but anyway, I've got it at 460 kilohertz. I'm going to increase this slowly till I get 12 volts. Yeah, it should be good enough. Thereabouts. Okay, now I need to adjust the second one from the top. And I can't show you this because it's way at the back there, and I'm going to adjust it for the maximum voltage. And I may have to... How the hell am I going to do this? Got to get around here without getting shocked. And also, I've got to feel for which one I'm actually adjusting. Well, I think you can sort of see what I'm doing now. I hope. That signal's too hot. Bring it down to 12 volts. I'm just changing the amplitude on the signal generator. It's close enough. Now I think I'll be able to see what I'm actually changing, and we've got to keep an eye on that guy over there. I can see through the top here. Bloody hell. This is not easy. Try with my chopstick or kebab stick. Make sure you choose the right cores to adjust. For some reason, the way I understood it, the ones we needed to adjust were the bottom ones here, closest to the top of the chassis. In fact, it's these over here. So I'm going to try that again. I'll show you the meters as I adjust that one there. That's for the voltage, and that there's for the zeroing of the microammeter. So let's see how we get along. Let me just show you the meters because I need space there. Okay, we've got this ready to go. I'm going to adjust the one for peak voltage. I've got that on 460. Still got to pull this out. Bloody hell. What a nightmare. Going down, going up. That there is a peak there. Okay? And now if we look at the microammeter, it's slightly to the left. I'm going to try and center it with the second one from the top. So you see, you can actually adjust it, and we need it right in the middle, like the, oops, the minute I took my little adjustment stick away, it went back. So we'll try a little bit more. That's about it. Right, I'm going to redo this without all the stuff tied up because this is driving me nuts. All these wires around here. I'm going to get a shock, I know that. So let me do it one more time and then we'll test it. Well folks, I think you can see from the battle zone that things are getting a bit complex here. For some reason, I can align that as I showed you, or tried to show you rather, but I cannot get this thing to change its behavior. When I align that to the 460, this thing's turning all the time. Now what that tells me is that this thing is not aligned to 460. What am I noticing here? I can get this thing to stop turning by itself when that frequency up there is at 458. And that is weird, because that's exactly the IF frequency that this thing was optimized for. Now it very clearly says 460. It was actually set at 458, and I've got a feeling, and again, this has happened to me in another radio before, something is aligned to a different value for a reason. And I think the reason might be that that motor IF transformer, or that motor transformer, is settable at 458, is peaking at 458. So what they did is they just changed the whole IF alignment. Maybe that's it. So I'm just wondering if I shouldn't reset this to 458 and see what happens here. In other words, can I get this thing to stop? Because at 458, or rather at 460, this thing's turning all the time. Now it should stop at 460. And then if you put it at 461, 62, it should turn one way. And you put it at 459, 58, it should turn the other way. It's not doing that. It's actually stopping at 458. So I'm going to have to do a bit more reading. I can't remember what I did with the other guys. I think they worked out perfectly well. I actually had to look back at the Breisgau one, and that was just a piece of cake. This one's being a bit more stubborn. So what I'm going to do is I'm going to take a break for now. I'll post this video, work on it in the next few days, and get back to you as soon as I got some news. Yeah, sometimes the end is frustrating, but we're not there yet. We're not there yet. So I hope you've enjoyed that. And if you have, click like, share, subscribe, and all that jazz. And if you want to support the channel directly, you can do so on Patreon. Thanks for watching. Bye for now, and stay safe.